We're dealing with rotations, and what we're going to do is take these two coordinates, A, B, and put them together as a line segment. So you can see I've done that already. A is at 2, 1, B is at 3, 4. And we're going to do the same thing with point C and point D. We're going to put them together. C is at 2, negative 1, and D is at 4, negative 3. So I've got these two short line segments. The question is, are these two line segments that we've created truly a rotation about the origin? Here is the origin. So what that's saying, and you can think of this if it's a rotation about the origin, it looks like this is going from the first quadrant to the fourth quadrant. What I see here in the first quadrant, if this is truly a rotation, it should look the same if I spin and take a look at just this fourth quadrant. And it looks like they are. If you can see that it's totally different, you know it's not a rotation. If you think that it probably is, and I think it's going to be here, then we need to do a little bit more work to show that it really is. What I like to do is go from the origin to the closest point. And to get there, I'd be going 2 up and 1 over. Now that same thing should be happening over here if I turn the way I'm looking at this quadrant and go from the origin to that point. I'm going 2 up and 1 over. So that's the same. Going back here to go from the origin to that further point, point B, I'm going up 4 and 3 over. Is that happening over here when I rotate about the origin? Up 4, 3 over. Yes, it is. Okay, so to get to those different points from the origin, it is the same distance in this line segment as it is here. That is indeed a rotation.